This is the last session before the coffee break. We're gonna have 5 presentations. The first 3 are gonna be full paper spotlights, so 5-minute presentations, then a reproducibility paper and a full paper. So as Linas introduced me, I'm Domon Kostik from Tabula. Please welcome the first speaker on stage.
Hi everyone. Today I will present our paper, CALRec, Contrastive Alignment of Generative Large Language Models for Sequential Recommendation on behalf of the researchers from the Google and the University of Cambridge. I will talk about the motivation, methodology, experiments, and finally the contribution. For the motivation, we focus on the sequential recommendation task, which means the model will observe the user's sequential behavior and then give personalized recommendation on what the user will buy next. We already know that the pretrained large language models could embed word knowledge. It could also enrich the rich information of the given text descriptions. So we want to leverage the power of large language models and frame the sequential recommendation task as a text generation task. So the recommendation is given by matching the candidates with the text decoded from the large language models. And the large language models could be fine-tuned with a contrastive loss. Zoom into the details, our approach is a pure text method, which means it only takes text as input. And we define a prompt template. First is an overall description, this is a summary of the user's purchase history. And then for each activity in the user sequence, we add an item prefix, like the first or the next item both is as follows. Then we add the description of the activity's attributes. To compose the target item sequence, we use the exactly same attribute template. For model training, we have a 2-stage fine-tuning. First, train the model on data of all categories, and then fine-tune the model on category-specific data. For the training objective, we combine the next item generation with contrastive loss. Here are the details. The 3 squares mark the 3 loss items, which are summed up together to our final training objectives. And in the blue square is the sequential loss, which is normal for the next item generation. And for the contrastive losses, here we have 2 large language models. They are actually the same one, share the parameters. On the left side, it takes the target item as input. And on the right side, it takes the user history as input and output 2 things. One thing is the representation of the user history. And the other thing is the representation of the target item conditioned on the user history, which is also the representation for the text decoded from the large language models. So the idea is we want to do the item level alignment. Meanwhile, we want to avoid the model to simply repeating the items that the user already engaged previously. And here the representation, we just means the mean pooling of the corresponding positions. For the retrieval part, we use a large language model to do the temperature sampling to get us a list of seeds. And then for each seed, we do a BM25 retrieval to give us a list of recommendations. And then we just get a 2D matrix of candidate pool. And then finally, we use a round-robin method to select the final recommendation list among this pool. We also observe that in the data set, there are cases like 2 data has different ID, but exactly same text attribute. So we suggested for the pure text method, we should report both optimistic and pessimistic metric scores, which means in the above cases, whether we rank the ground truth label to the top or to the back among all the tied items. For the experiments, we use a 5-core deduped Amazon review dataset, and we use all 4 attributes. For each sequence, we split the position in the normal way, like the last one for test, the previous one for validation, and the further previous one for training. Here are the experiment results. Like our method is the purple one, and we can see that on all 6 categories, our method beat the baselines by a large margin on the recall at 1 and NDCG at 10. And our baselines include both the text-only method and ID plus text method. Yeah, this basically just summarizes our contribution, and this is pretty much for my presentation. Thanks for listening, and feel free to drop by our poster for more discussions. Thank you.
Thank you.